Here, record this video. Hi, hello everyone. Welcome to our camp 40-40-23. And this is the first class we have this semester. And at the same time, I would like to mention this is actually the first time we're offering this computer vision course to undergraduate students. So that's the reason we got you students here. I'm not sure the computer vision is supposed to be a very popular course in other universities that we just have you here. Maybe it's the first time. Maybe some of students are scared. It sounds like top course for them. Anyway, I'm sure this is an interesting course, and you know, computer vision is a very hard topic nowadays, and I will try my best to make it fun. And so let me just assign one more core host for the room meeting. Okay. Those online guys, if you can't hear me or you have any problem related to this room, just let us just send them in the chat box and our TA will deal with it. So anyway, back to our course. This is the first time, so I'm trying to make it fun, and also I encourage you to invite your friends and classmates to here to join our course. So let's get started. And first, I would like to mention this hybrid teaching. And for those online, please, every time when you join the classroom, please mute your microphone. And also, if you're asking questions, raise your hands. From those, there is a reaction there. If you don't know how to do it, that's a place to raise hands for asking questions. And if it's not an urgent question there, you can send your question in the chat box and the RTA will deal with it. So, okay. So for those guys coming face to face, and we just follow the usual procedure. My name is Xiaoyong Wei. I'm the subject lecturer for this course. Right now, I'm visiting PolyU as a visiting professor. Prior to that, I have been visiting Tampere University in Finland. And also, I am the adjunct professor in Pengcheng Lab, which is located in Shenzhen. Maybe someone know it. It's right now a national lab already. And I am a professor from Sichuan University in China. I'm also the department head there. I have done my postdoctoral fellowship in UC Berkeley years ago. And also I got my PhD from City University of Hong Kong. So Hong Kong is a place I'm familiar with. And also there is a barrier group doing computer vision and multimedia research. I'm one of the founding members there. And I'm also senior member of HFB. Okay, this is almost about me. If you're interested, you can go my homepage, and you can find them easily by searching my name. And for this course, we offer office hour there, and it's right now due to the pandemic, it's not a good time for office hour, but I will be there every Monday after lectures until 5 p.m. there. So feel free to drop by my office for interaction, communications there, conversation. And also, it would be better, you can send me email to make the appointments, or you can talk to me through phone. This is my phone number of the office there. Okay. we use English mainly in this class, but I speak Mandarins there. I know some students that speak Mandarin. I'm a native speaker of Mandarin. So should you have any question, you can ask in that Mandarin. At the same time, I know some students are speaking Cantonese there. I'm pretend to be a native speaker there, and we can, if you have questions, ask in Cantonese, will be okay. So, okay. So we have TA and here teaching assistants, Liu Ming and Ren Jie here. They are here today. Please raise your hands to let me know. Okay. So should you have any question, you can find them as well. And most of the time, during the class, during the break of these lectures, we'll working around, talk to you to make sure to answer your question and make sure everything is going correctly. So, okay, this is about almost about myself and our the arrangement for this course. Anyone asking question there? Okay. Double check. Okay. For those online guys, if you have any question, you can send them in a black box. If you can't not hear me, you can ask directly. Turn on your microphone. I wouldn't mind. So just for most of the time, you have to mute your microphone here. Okay, back to the course itself. Computer vision. What is computer vision? Before you come here, have you done any research on that? What is computer vision? Oh, you did that. Okay, I see Stephen not. Okay, would you want to share something about computer vision? Oh, you have experience in computer vision. Okay, just tell us briefly about your understanding about computer vision. Okay, that's great. That's great. Thank you. So by answering the question, you can actually sit down there. You don't have to stand up. Okay. We probably grasped something from him about the computer vision. Computer vision can be used for the healthcare related research. It's really helpful. And I'm happy to have you here and to provide that kind of perspective. However, if you are asking me that question, I probably will say, I have no idea. I don't know. I don't know how to tell people what computer vision is. However, I can also, like what he did, I can provide some clues about computer vision. First of all, I know not everybody knows nowadays because everybody got cell phone here. We take photos every day. We take videos every day. It's going to be a lot there. It's every second of this world, there are a lot of pictures and the videos being taken there. So I think you're familiar with those. So because we're doing that every day. It's got to be something related to images and the videos. If you're talking about computer vision, I think this is the first impression that everybody has. So, but I don't know. It sounds like it's quite related to our daily life. However, to have a better understanding about the computer vision, we can actually play with it. So let me show you some example here. So I prepared, and this is one. I'll share the lecture notes, and also I will share those links, so you don't have to worry about it. And this is one of the example, online example, which is for handwritten character recognition. And those are for numbers, like I have written 7. You could see, oh, they made it wrong. Actually, this is a response. They are recognized as 1 or 2. It happens sometime. Let me try another one. Okay, let me try 8. Right now, you see it's a 8. Now, and let me try a 6. Okay, it's a 6, and also it's very similar to a 5. That's the reason there's a comparatively higher response from 5 than the other digits, but the 6 is the one with the highest. Let me try one more. Okay, this is a 2, and also it has been recognized as a 2. So we previously we got a lot of handwriting documents there. It's a headache for some of the administrative guy and for the banks as well to recognize this handwriting stuff, and also because nowadays every bank is using the computers. It would be good if we can convert those handwriting stuff into digital documents. So this kind of technology called OCR, that means to convert the handwriting things into the digital stuff. And that means also recognize those handwriting characters automatically. So this is one of the application. The research about this start from very early years of computer vision. So this is one of the example I would like you to have. And let's check another one. And this is a one with a fancy interface. So this is a demo. Let me just click one of the image there. So you will see this is an image about a cat. And also at the same time, you see here, there are some labels about this cat. Actually, it has been recognized as a cat, and the confidence likelihood is 99%. So this is a result. My right hand is the recognition results. You will see it has been recognized as a cat. Very confident. The computer is very confident about that. And also it's a pet, and also confident about that. It's a mammal. It's with high confidence, but not that high as cat and pet. And also computer are also recognize something else there. So this is one typical application called image recognition. That means we're trying to use the computer to recognize the content from the images. And also the same technology can be used for videos as well. So because video, it's just a sequence of images. You can apply those kind of image recognition method to videos there. However, videos have something different from images there. We will talk about it later. And anyway, it's intuitively, we can use this. Let me try another one. Okay. Now, it's been recognized as a social group in clothing, people, and so on and so forth there. And also we can try other stuff there. like let me just do it here. Okay, this is another example. And anyway, there are a lot of them, and you can I'll put the link there. You can play with it by yourself. This is just for give you for help you to build some intuitions about computer vision. First is the character recognition and image recognition. Actually, there is one combine these two together. This is an image recognition at first, and also it recognizes those texts in that picture there as well. You see here, this is the address of that, which has been recognized from the image. Anyway, this is I think this is a fun demo, online demo. You can play with it later to get more understanding about computer vision. Another one is there are two images. Do you know who they are? Looks familiar? A little bit, right? And you know who they are? Is someone that you can tell their names? Looks very familiar, right? But I'm not sure, and you're not sure who they are. And this one as well, actually, you see, there's a link called "This person does not exist," because those persons, those people are actually the images. I mean, are generated automatically by the computer, so they are they do not exist in this world. It's artificial images there. We can go there actually. Let's play with it. So every time you are accessing this web page, it will, let me just use this one. It will give you one an image with one person who doesn't exist in this world. Let's try that. Okay, it looks so real, right? It looks so familiar. So how can we do this? We can, I think after this course, you can do it by generating such kind of images there. It's like so real, but they are fake. They are not real persons. So, okay, that might be one of the example. Another example give us more impressions about computer vision. And also this one is very similar, more for Asian faces there. I already posted a link there, so you can try it later. And this one, trying to, you can use this one to make some cartoon characters there. And at the same time, you can adjust the hair color to put the hat and to make her smile. And also you can change, you see here, there are a lot of parameters you can play with. And maybe you can try it later. So we got a very limited time today. The schedule is tight. You just have 2 hours there. There is another one. This is a news. This is a picture which has been sold a couple of years ago, very recent. It's a fake one. It's very similar to the fake person created by that website. So but it has been sold. You see the price here. It's 43. It's 432 hundreds. Their dollars. This is digital arts because one of the first was sold for real money there. Fake art sold for real money here. So this is another example, give you the feeling like we're not just playing with it. The people are make it more serious in the future. So people buy it. Okay, just to give you more feeling. And also you probably have learned there are a lot of other applications there, like this unmanned vehicles. This is a Tesla on the model of autopilot there. That means the car will drive by itself. You don't have to do it. It automatically recognize what's happening outside the car on the streets, avoid to crash into other vehicles there, and also bump other people's there as well. So this has been told a lot in the news and also on the social media. So I guess you're familiar with this, right? Because they got a lot of news there. So the basic thing, especially for Tesla, they rely on the computer vision a lot because in their announcement, there are actually a lot of technology has been used for those self-driving cars. Most of the self-driving cars, they use a lot of sensors, like laser sensors, to determine the distance of objects to the car. However, Tesla is different. They are trying to avoid using such kind of sensors there. So they are basically based on computer vision. That means they are based more on the cameras. So this is mainly about the computer vision self-driving car. So that's something related. And also you might already saying computer vision can be used to recognize objects from images. And these are some results, examples there. It's kindly different from the one we have shown to recognize the cat, because there is only one object, the cat, inside that image. This one is kind of different. They detect where the objects are and also tell what the objects are at the same time. So, and you probably already seen this. And also semantic segmentation, trying to tell the region covered by each of the objects inside that image, and also distinguish them from the background. This is semantic segmentation. You probably have learned this somewhere else. And also style transfer is trying to change one image into another style, as you're seeing here. Probably you're already saying that you already learned this from the news or social media. So in that case, I'm going to escape. Okay, so from here, you probably get a feeling that computer vision is everywhere, like self-driving cars for safety reason, and monitoring for surveillance video there, they use computer vision app, and also medicine or health care stuff. We just have one student provide one example there, and the robots and the other stuff, they're gaming there as well. Computer vision seems like everywhere in this world. So up to here, what is computer vision? Let me ask this question again. It sounds like there are a lot of stuff there, but we can not tell exactly what the computer vision is. We have got more understanding through those examples. But those examples are what's happening right now. I think it will be better. We can look back the history of computer vision to get more understanding there. Okay, so let me give you a brief history about computer vision. It started from the early 1960s. And at the very beginning, when people are talking about computer vision, there are many pioneers, like the scholars from MIT, Stanford, and CMU. They all thought computer vision should be an easy problem. You know, for example, this is a very well-known one. The Professor Marvin at MIT has assigned their undergraduate students to spend their summer building application using the computer with the camera to describe what it saw. So it's very similar to the image recognizing stuff there, because they are that's it just for a task for a couple of weeks there. So that means Professor Marvin thought it was an easy task there. However, nowadays we know it's not easy. However, no, you see here what they have described is a name, the superclass, the subclass, the number of wheels, length, or something like that. This gave a very basic framework about the recognition. After that, there are a lot of research are trying to, people think to recognize the stuff, the objects from the images, maybe we should have a representation about that. So this is some of the example at the early years. They are using very simple structure to represent the object. This is taking a person as an example. You see here, they are using the cylinder to represent a person with different parts of the body. And very similar one, I guess you're familiar with the Minecraft. They're using the blocks. So it's still using nowadays because it's very simple and efficient. Also, they are using the matchstick man. You probably already seen this there. So these are starting from very early years. People are trying to use very simple structure to represent the objects they see through the camera. So, however, when later in 1990s, people, we have more computational resources. The computational power becomes, the computers are becoming more powerful there. People are more ambitious there in between. They're trying to recognize or build more complex structure of what's happening there. You see through the camera. So there are some examples. For example, people are trying to recognize the depth of the camera. That means how far the object from the camera. If you have, I'm not sure anyone has played with Kinect games. One Kinect game from Microsoft. They have Kinect camera there, which can recognize the depths of each object from the camera. They're not at very beginning, and they are not relying on those computer vision stuff. They're using more the refresh camera to do this. But if you consider the refresh image as well, they're using computer vision as well. So anyway, nowadays we have tips camera specifically for this task. They're much more accurate than before, but at that time, people are trying to recognize those tips from the image directly. The normal image I will talk about. Sometimes we call them RGB images there, which I will introduce later. Also, they are also trying to use the image taken from multiple viewpoints to reconstruct the 3D structure of images there as well. So we have a specific lecture about this later. but it's starting, you can see starting from early years, people are trying to do that. But at that time, they're using different methods I will introduce. Okay, anyway, compare back to what I have introduced previously. I mean, a structure, this is more much more complex than the something like the match man, right? So also they have extended this to face. They're trying to to recognize the structure of the face, and for application like the face tracking, and also during that process, segmentation, image segmentation, even we have to introduce the semantic segmentation. They start very at the very early years for this task, but at that time, the main purpose is to distinguish the foreground from the background. So that's very simple task there. And also it has been used for facial recognition. We got a lot of news about that. I'm not going to repeat that. But here, what I want to say is to start from very early years, using very simple method there. At the same time, people, because people are exploring this area a lot, they realize there are much more application there, like the image stitching is very interesting stuff. Actually, if you got a smart camera, a smartphone, you have that function inside that. There is, when you're taking a picture, there is a panel, that means panorama picture, which you move your camera and they can combine this series of images into one. So you have a very wide view of images there. I guess you've already tried that, right? So this is image stitching. That means you can stitch multiple images there as a whole. So you have a wider view about what you can see through the camera. So most of the time, there are some overlaps in between those images there, which you can use them as a reference for stitching. And also, there is some application trying to find the best exposure for image, because if you're playing, you have the experience playing with digital cameras. You know that different objects has a different exposure parameters there. So the idea here is we can combine the images taken at different exposure into one best images there. Actually, nowadays you have that in your smart phones as well. There is a HDR, right? If you play with your smartphone, I'm not sure how frequently you play with your camera, but I guess nowadays most of the camera, they have the HDR function there. If you're using HDR function, that means the camera will take several images at one shot with different exposure parameters. And later they can use that to combine them together for a better one. So that's the idea, start very early here using different methods. And also morphing and trying to, like you see here, trying to combine images there. You see there is women there, and at the same time there's a tiger, and it gives us something look like a tiger women there. So blending them together. So this is one of the things. Those are very popular at that time, before 2000. But people soon, because before 2000s, for those kind of stuff, people are working on several images, not necessarily several, but very limited number, like 100, 200, something like that. in a very small scale, and they have to build a specific model or algorithm for such kind of images. But at the same time, because the method itself or model themselves are too specific, it cannot be generalized to the other images or in other applications there. So there is in 2010, people built this ImageNet data sets. You could see there is not like 100, 200. The number of images are up to 1 million there. So there are 1,000 object classes there. So people are trying to use these very extremely large data set of images to conduct those application or research topics I have mentioned previously. The idea is if your method can work in such large scale, it can be applied to other applications. It's more we have a term for that called generalizability. It can be general. That means it can be generalized rather than us just working a very specific domain there. So this is an effort the community, computer vision community spent at that time, and people have tried use the method they built previously on this new data sets, but without too much progress, because as I mentioned, those methods are specifically built for a limited number of images there. However, at the year 2013, here comes the game changer, which called AlexNet. It's a deep learning. It's not the first deep learning framework, but it's quite successful because it beats the traditional method and model badly by just stacking those deep layers there. The method itself or framework work itself is not that complex. However, it's got a very good performance that year. So, a lot of people think this is a starting point of deep learning method into the computer vision. So it's a game changer. You can see from here, before that, people are using the traditional way to conduct experiments. However, when AlexNet come, the performance has been increased a lot there. And later on, here are more deep learning frameworks coming, like the Inception, like the ResNet. Those are very popular deep learning frameworks there. I will introduce this later. So anyway, you could see from here, the deep learning is a game changer for at least for that data sets. But indeed, it has already changed what people are doing in computer vision. So that means what we are doing today, most of them are completely different from what I have introduced in the early years. I mean, the methodology and also the way thinking about those topics and problems there. So, okay, I think that's just some of the example to help you to grab some of the feelings about the computer vision. And we're not making a conclusion yet. So let's take a break for 5 minutes, and we can come back to that later. And at the same time, we have a survey on the Blackboard. Please take your time to complete that survey. The purpose is to help us to understand more so we can customize this course for you. So, okay, anyway, let's take a break for 5 minutes. And I'm kind of working around in the classroom. So if you have any questions, we can talk. Okay. Let me check out the any question from guys online. Okay, it's okay. Okay. Let's just continue about our topic. We're kept keep asking ourselves what computer vision is, but we didn't make any conclusions yet. The reason is you could see from the applications there today, and also the brief history I have given, it contains a lot of topics, a lot of challenges there. We can't actually give a conclusion what computer vision is, because it's still changing there. It's still developing there. So, but however, that's the reason we have to catch up with this idea, because it's so important and it's so popular there as well. And I guess it's very interesting as well. And so I'm trying to, I know I learned that because it's the first time while offering this course, a lot of students may have a concern. This is a tough course, and so they haven't actually picked this course, but you guys are very brave. Thank you for coming. But from we are trying to make it fun, so we are trying to make it interesting, and I would say don't worry about that. It's not that tough, but I'm sure it's interesting there in between. So we are going to learn. We don't exactly know what computer vision is, but we're going to figure it out by playing with it. So, and here is one example. I would like to give you one example happening in my class previously, also computer vision related course there. It's called in-class social network mining, and that's what we have done years ago. And before that, let me ask you a question. Do you like attendance check? No. You're shaking heads. So I guess most students they don't like the idea of attendance checking. However, it sometimes we have to do it. Why not we make it fun when we have to do it? This is a question we asked years ago in my previous computer vision related courses there. So this is what we have done there. We have to make it interesting by the idea is at that time, because it's something like 10 years ago, I have to mention. At that time, the facial recognition is not reliable like today. So we come out of the idea to do the attendance check. Because I don't want to do the roll call, it takes time. So I take a photo in each class, and I publish that photo in the course homepage. And also, they could go the course homepage to take where they sit in the picture. At the same time, they do the attendance checking. And this is what we have done. We taken a photo at that time because the classroom itself is large. And however, we cannot take the whole class with one picture. So we take several there. So with that picture, we used image stitching. I have introduced previously with that example to stitch multiple images together as one image there. So we can upload this one image. Before we uploading them, we're using the face detection to find the faces inside that image. And we upload them to the home page, and people can check there where they sit in the classroom. At the same time, we do the attendance checking. It's 2011, something like that. So, and later on, because this checking has been done manually, so people have to take the picture by themselves. But later, we think why not we take a step further, because we are learning the facial recognition in that class. Why not we just use it? So the idea is we can integrate the facial recognition into that checking task. At the same time, we can analyze there is an in-class social network inside that classroom. I will introduce later. Here is a framework, and here you could see we take photos for the class and we stitch them there as a whole, as one image. And the student, we use the facial recognition to recognize who they are. And using with that information, we can construct the network of the classroom. And we use a network to help with the facial recognition, because as I mentioned, the facial recognition at that time is not that reliable. So we're using the network inside that classroom to help with the recognition. That means we are not recognizing people one by one, rather by group, because some students sitting frequently because there are friends there, the peers together there. We can use that information to help with that recognition. So that's what we have done. And this work has been published in one of the top conference in computer science. It's a multimedia there. And also at the same time, you see, we can recognize the network inside that classroom. You know, there are some of students are quite active inside that classroom by have those interaction with a lot of students there. However, some of students are not that open there. They would stay alone there from the others. And also, we use that information to do analysis by comparing those how open they are, how frequently they communicate to people to their final grade. We found that the more they're talking to others, the higher their final grade is. So encourage you to talk to others there in a classroom. At the same time, there is one thing very interesting is there are a lot of sayings that those guys sitting at the front row will perform better than those sitting at the back row. I guess you have you have heard about that sayings a lot. So is it true? So we have used this data set to verify that, because with that image, we can actually calculate how far each of the students from the teacher. So we did another analysis there, and here's the result. And also at the same time, we have checked. There are some previous study by those educational or psychological researchers there in between are starting the same problem. However, at the same, but the way they're doing is case study. That means it cannot be conducted in very large scale. But right now with that images, we have students over 400 there. We can have, this is very large data sets compared back to the case study they used. So actually previously the scholars have two different understanding about this. Some people are saying if you're sitting you're sitting in the front rows closer to the teacher, the performance will be better. And there are other group of scholars, they don't believe it. They mentioned there is no such kind of relationship inside that classroom. So this is a conflicting understanding. However, with these data sets, we found they are not actually conflicting to each other. The reason is their data sets is very small. Most of the time, it's just several students, like 4 or 5 there. So that means it's very arbitrary. Their results were based on the sampling. If your sample, they are sampled from some of the area like this, that means there is no any, this part, meaning that if it's far from teacher, and you get a better performance there. But there are just several examples there. But as a whole, you could see most of students at this part. Here is a regression result about that. And you could see from there that it's true if you're sitting closer to the teacher, and you get better performance there. I guess it's due to the reason if you're sitting in the front rows, you have more interaction with the lecturer. And actually, when I'm giving a lecture, I actually are checking out your faces there to see what kind of emotion reaction from you. And if you are appear like you confused about some of the concepts, I rather say it again to help you. That's in that way, the lecture is kind of customized for you than others. So anyway, this is something we have done there. And the conclusion is the facial recognition can be used for such kind of analysis. And also, it's not indeed that boring for attendance checking. You see here is the first time we're doing that in 2011. There are 42 students there inside that class. And however, the next year, there are more than 100 students coming for that class. And most of them are actually coming for that attendance checking application. Okay, so it's useful and interesting, and I'm going to use that in this class. But don't be scared. We're not going to use the facial recognition, and we're not doing that for attendance checking. We will not check the attendance, but it's just for fun. And at the same time, because the application itself will help you to understand the idea. We're not, I will introduce later, we will build a seminar application there, but not using facial recognition. Okay. So after that, indeed, because you could see it's something like 10 years ago, we're using that, but later we further developed that application. And here is one we developed, and check if it worked. Okay, yeah, it works that way. So we are using the very similar technology to see if students are bored during a lecture. So in that case, we can customize, as I mentioned, we can customize those lectures for them to have a better teaching and learning experience embedding. So, and that's one thing we have further developed. And also here's one video. Let me. This is from one of the media from China. This is one thing we have further developed. We're using the drone to check out, to replace the camera because the drawing can flying around the classroom. So that's one interesting thing we have done. You could see there we're using the facial recognition, emotion or expression recognition in between, and there are a lot of tracking stuff there as well. So anyway, this is one, okay, this actually attract a lot of public attention there. We have been on the news a lot, and even on BBC and Telegraph, they're in between. And what I want to say today is we can use the similar way to learn the computer vision. So that's one step, a step we're going to take today. I have built one application. It's called I'm Here. So the idea is we can re-implement the attendance checking stuff. Okay, excuse me. So the idea is we can re-implement this attendance checking stuff. However, we don't use the face as a token for your identity. We can actually use some token you picked up for yourself. For example, I have picked up one of those. So it's a toy car, and which can represent your identity. We can use the computer vision method to recognize that car for identify your identity. So here actually is a QR code for that web application. If you scan the QR code there, you can scan it later. So if you scan the QR code later, you will be directed to a registration step, which you can use, pick up a username, input your student number, and set the password on that. And then you're asked to provide the images of your token. You can take 5 of them. One is the front and top, and the back view, and the left and the right view of that token as a registration step. And after registration, and every time when you're doing attendance checking, you can take the photo of your token together with a picture of that day, because we are changing that background image. So then we can build a problem for recognizing the token and the background image at the same time. So once everybody have registered, have image collected, we can open this data set for everybody inside this classroom. So you can build your algorithm on that. And also actually initialize one GitHub project for this. So with very basic framework about recognition, about this web application. So we can replace the components of that GitHub project together. So and here is like after registration, and you can take the attendance check. This is a picture of the day. I will show up that image. So after we have the data, we will run a lot of images there. We will run, we will have images there. Currently, it's very ugly, and this work with that part later. So right now you can try it. You can try it by scanning that QR code and for registration. And once you have registered, you can take the photo like what I have done there. And you to check it out if it can recognize your token, you can take like I have taken the toy car. You can, for example, anything you have here, but make sure it's unique for you. It will help out the recognition. So You can try it out. This is a picture of the day. It's changing every day. See if you can. Sorry, it's just the password can you can only give a 6 digits password. If you give more, probably goes wrong. As I mentioned, it's a very it's at its very early stage of the development, and I will have that part open sourced so you see what's happening, and we can improve that project together. And students who contribute to that open source project, we will give you bonus. After you submit, it takes time because it's uploading 5 images there. One RTA already got 16. For example, yeah, you can take your token with your computer screen with the background. You're in a room. For example, he's using the mouse. Every time it takes time. Uploading the isolation, it's at very early stage of the development. We're using very simple. Well, sometimes it's just depends on the likely conditions around. We're currently using a very simple algorithm to do the matching. Anyway, let's figure out why, and I'll let you know what the algorithm is and why it doesn't work in some of the situations. That one succeed. It's expensive though. So the front end is extremely healthy. Mentioned it's at very early stage. We focus on more on the matching rather than later we can do a better design with the pictures after the progress. But right now, after something, you just have to wait for seconds. We're ready. We have the first two are my username. So we currently we have 1, 2, 3, 4 students already there. Especially, it's not that a powerful server we're using. No. So I got a very good question there is, so when you're doing the registration, you're providing 5 images there with different view of your token. However, when you're doing the checking, you can upload the image from either of those views. The reason is you will learn soon. For registration, we just have to make sure we have enough data of your token. However, it can be matched from any of the view actually. So this is one of the things you have to deal with when you're doing image recognition, because the viewpoint change will make the matching more challenging there. And this is one thing we're going to teach in the future of this course. Right now, we still got just 1, 2, 3, 4 of them. The other 2 are my students. So. But don't worry, if you have already registered, and but when during the attendance checking you failed from the checking, and don't worry about that, because I mentioned the algorithm itself, it's at its early stage. We can improve together later. But in case you see check failed, that means your image has already uploaded to the server. That means the images are already there, and we can use that later to improve our algorithm later. So even you failed with this, maybe you can succeed in the future with a better matching algorithm. So I'll give you 5 more minutes to do it. Let me check out if there are any questions from the online. Is there anyone from online you succeed already? Time's out. Okay, I know there are still a lot of problems and issues in between, because as I mentioned, it's early stage. It times out because right now we have more users there. Even it's not that many, but it's definitely will raise some challenges for our server, because everybody is uploading very large images in between. That's the reason it may times out, and you might be kicked out from that registration process. And later we can find a better server. Right now, the one we're using is one with very limited computational resources there. If you're trying with L6C, you can actually keep, I think you can keep the QR code and you can try it anytime. Let me see if I can send this QR code to the chat box. Let me check. Unfortunately, I can't. But I can send the address, I guess. Let me send the address directly. Yeah, you can visit that address. Indeed. And this is not a picture for today. This is picture for today. We have one more student get succeed about the checking. So not that bad. So anyway, it's at a very early stage of developing. That's the reason maybe you still failed there. Okay, anyway, let's just continue with this. We're going to learn a lot of topics related to this application. You know, there is something you're going to learn very soon in the next lecture. So after taking the reason one may fail in this application is because we are uploading a very large image to the server at the same time. It's really a challenge for our server because it has to take the stream, the pictures from multiple users there, and they are very large data. One way to solve this problem is we can resize that image to smaller images before uploading them to the server. So this is one typical image processing problem we're going to learn in the next lecture. And after those picture uploaded to the server, the next step is our server has to extract some of the features. That means it has to check out what's special in this image. And also with that feature, it's compared back to the images you have registered. So once it's matched, we know your identity. We know it's yourself are doing there because you're the one who is supposed to have that token, not anyone else. So this is basically what we're doing, and we're going to learn such kind of thing in the future in this course. As I mentioned, don't worry, we're not using the face. We're using token to make you feel more comfortable about that. And as you're saying, the UI, the interface is extremely ugly at its current stage. So we need volunteers to build this. And also at the same time, we are very generous about the bonus. So specifically, if you have the experience of working on front end, that's a part we don't have too much experience. That's the reason the interface are extremely ugly there. So it will help if you have experience in that part. We can work together to improve the UI to make the user feel better, have better experience. For example, when you're uploading the images, we're supposed to let the user know it's in progress, rather than the interface stuck there and people have no idea what's happening. Is it succeed or it's actually doing something? So anyway, we need the front end programmers to improve that part. And also, I have initialized GitHub project, as I mentioned. We are going to upload the source code we had currently to that project soon, so we can work together. And you know what's happening inside out. You know what kind of technology or what kind of algorithm we have used for developing this application. So this is a way we learn through our real project, and we're going to do that this semester. At the same time, we will initialize several challenges there. So this one is one example. Once we have the data collected, we, as mentioned, we will make it available to everybody here. So we will run challenges there on that data set. For example, we can run a challenge just about the recognition of identity. The winner, we will give the winner bonus, and they're in between. And also there are other data sets. We're going to raise challenges there as well. And in the same way, if you win that challenges, we give you bonus. So, and this is the way what I have mentioned, learning through playing playing with it. Okay, that's a project. Okay, this is almost everything I have to tell today about the computer vision. And for the course itself, and here we have a tentative roadmap for that. And this is lecture one is today. We give introduction about computer vision and what we're going to do in this course. And from next week, we're gonna introduce image processing. We're going to spend 2 lectures for that actually. It's the basis of the basis. Like the one of the problem I just mentioned, we can resize, we can shrink the size of image before uploading. It's a typical image processing problem. And in the next lecture, you will learn how we can do that. And we will do more in the lecture 3, building upon the basic image processing algorithms to learn better. And also in lecture 4, we're gonna introduce the feature extraction. The feature extraction means computer actually recognize images not directly from the image itself. It's recognize something like the shape, the color, the texture, and also the other recognizable features from there before give decision conclusion on the content of that image. So feature extraction is for that purpose. And after feature extraction, we're going to learn image retrieval. I guess you have used a lot of image search through Google. That means you can search images with either text information or using image as an example to conduct a retrieval. So we are going to learn how we can do that with the method we have already introduced. And also after that, we will introduce image classification. The one example, the cat recognition, is a typical image classification task. So we're going to learn the image classification, but like in lecture 6 and 3, we're gonna learn those traditional methods because I think it will be better for you to understand what happened there. But in lecture 7, we're gonna introduce the deep learning related method. It's the state of the art, but it's also people, I'm not sure you have heard people saying that deep learning is a black box. That means sometimes it gives you very good performance, but you don't exactly know what's happening there. So in that case, I will put it in lecture 7. That means when you have very basic understanding about the image classification, especially with those traditional methods, then we can go the deep learning part. Okay, I think that's a better way. And in lecture 8, we are, because we have introduced deep learning and the image retrieval and task, it has a lot of things related to deep learning. So we're gonna introduce more advanced image retrieval method there. And later we update our understanding about the image classification as well, because besides image recognize the object from the image, there are a lot of things are related there. And then in lecture 10, we're gonna learn the 3D representation and the risk construction as the example shown earlier. I will introduce methods about that. And then in the rest of 3 lectures, we will introduce more advanced topics. But those advanced topics are more for extend your understanding about computer vision. That means you don't actually have to do it with the you don't have to write a code for yourself. I will refer you to those open source projects, and also probably I can give you some of the code. If you're interested, you can further develop in that directions. And also we will discuss the course projects in the rest of the 3 projects. And after that, it's a final examination. So anyway, this is a tentative roadmap for that. And the course websites are Blackboard mainly. And you can find everything there: the announcements, slides, assignments, projects, and also the web app we have already used today. That is the address for the web app. We're going to build this app together, and at the same time learn the concept behind together. And here is a timetable for the lecture. It's every Monday from 12:30 to 14:20, and starting from week 1 and through week 13. And we have the tutorial session starting from next week. We don't have the tutorial session today, or lab session, tutorial session actually today. There are 2 tutorials, one starting from, one is this, the other is this one. And is it correct? There's overlap there. There is overlap to our lecture. There's tutorial 1. There's 1 hour overlap there. Okay. So, okay. So anyway, here is the time, but we can adjust because we don't have too many people here. We can adjust to find the best slot for you there. So anyway, we will public announcement for that if some change, in case some changes are there. And also, this is assessment. We have a continued assessment. It's including 2 assignments. Each of them take 15% of your final grade. And we accept late submission up to 3 days, but we will deduct 10% per day for late submissions there. And we have 1 course project which take 25% of your final grade. And also the final examination, it's open book and supposed to open internet as well. Let's see. It take 45% of your final grade. And we give bonus, as I mentioned, for if you contribute to the I'm Here project, and also you win the class challenges. As I mentioned, we will prepare some of data to run the challenges there. If you win, we give you bonus. And quite important, we have 0 tolerance to cheating and plagiarism. So be careful with that part. I guess. And here are some of the textbooks. You can use them as references there. And I will try my best to put the basis about computer vision in the lectures. I suggest you can use this book for checking purpose. Sometime if you want to learn more from that topic, you can go for this reference book. It gives more details there. And also the way we're learning is for each of the lecture, we introduce the concepts. At the same time, we provide some of the code for that. Let me briefly show you some example about our lecture too, so you will get a better understanding what we're gonna do. So this is this lecture notes for slides 2. You will see there we introduce the basic idea or concepts about each of the components, but at the same time, we give you the code and we will run that code together with you. And this code will explain how can you do it by yourself about each of the algorithm. So in that case, you'd better prepare a Colab, the Google Colab. It's free of charge, and you have it as long as you have a Google account. So it's actually a online Jupyter notebook. You can write the code there and run the code there. We're using Python for that. So I already got the survey results from yesterday. I learned that most it appears like everybody is using Python. So I suppose you're okay. I assume you're okay with that. So this is basically the way we're doing the lecture, and our tutorial will continue on the topic we have introduced in the lecture. That means the RTA will help you to actually run those code in the tutorial. And if there are some of the topics should introduce, the TA will introduce that in the tutorial as well. But the tutorials are more for build your hands-on experience. We hope that at the end of this course, you grasp the basic understanding about computer vision, and also at the same time, you can program actually for some of the tasks. Get you prepared for a lot of purpose there. Okay, that's everything I'm gonna introduce today, and I will upload those lecture notes to the Blackboard. So you, in that case, you can check it out with the examples we have demonstrated today. And also, as I mentioned, we are going to make it fun, make it interesting for learning. Don't worry about that. It's not that tough as you imagine. So I would like to encourage you to invite your invite your classmates and friends here. So that's all of it. See if anyone have some questions. Okay. Okay. We got some question from the chat box. Today's attendance photo again later. I have registered successfully. Yes, you can. Every time after each lecture, once you upload images, we will putting those photos and pictures together, and we will publish that through Blackboard, so everybody can download those images from there. So in that case, you can try it out by yourself. And okay. And also another question is, may I know the course project is individual or group? The course project is group. You can, starting from now, you can find your teammates for the group project. So that's the answer to that question. See if there are any more questions from online guys. Okay. In case you guys don't have further questions, I guess that's all for today. And I hope you enjoyed. Okay. That's the end of this lecture. And let's meet next week. Thank you. And should you have any question, especially for those come face to face, just come, we can talk.